Okay, how you doing? This video is going to attempt to help the person who is a visual learner take something that's in quadratic form, ax squared plus bx plus c, and convert it into vertex form. So this is my quad form, okay, quadratic form, and this is the vertex form. And what we're going to do is we're going to take just expressions and we're going to learn how on earth can I do it, but we're going to do it by construction. We're not going to do it by algebraic means, but the goal is to understand the algebra that's going on behind the scene. So something that is in quadratic form doesn't take into account the perfect square. The vertex form takes into account the perfect square. So what we want to do is we want to observe and try to find a perfect square. What we begin to notice is that this A and this A stay the same in vertex form, and there's a reason for it. This A dictates how many squares, how many perfect squares they're telling me that I need to build when I go into my vertex form. So a couple of things for the visual learner. Anytime I have an x squared term, we're going to use an actual square that is a length of x by x. So we're going to base everything off of area models. X tiles, so you see it says 5x. X, we're going to base off of the area of, really, x is this idea of 1 times x. So therefore, I have an area of a length of 1 by a length of x. And the last but not least, any number, so like we have 4. Okay, 4 is created by 1 plus 1 plus 1 plus 1. So we're going to use the area model of 1 times 1 still makes 1. So here's the tiles that we have that we're going to use to help us build that. So first things first, whenever you have these, you kind of really just want to draw out what you have. So I have an x squared tile, so I'm going to draw out my x squared. So there it is. Then I have 5 x's, so I'm going to draw them out. So 1, 2, 3, 4, 5. And this is just a quick sketch, no need to be perfect. But this plus 4, I'm never going to draw that out. Okay, so what we need to think about is that we need to make a square. And what we're going to build our square off of is going to be the x squared and the 5x. And we'll deal with this positive 4 in a little bit. But we're going to use it to our advantage. So I need to build one square. How do I know I only want to build one square out of my x tiles, out of all of my x's? Because the coefficient of x squared is 1. So I only have to build one square. And here we go. Let's talk about how we do it. We play literally the one for you game. The nice thing about squares is that squares are unique because they're proportional on one side to the other side. And not only they're proportional as a 1-to-1 ratio. So what is on one side has to be on the other. So this is the game we're going to play. So I'm going to take an x tile and I'm going to start to try to build a square. So there's 1. Okay, there's 1. All right. So now some people might say, why don't I build around the whole side? I really don't want to get around building the whole side because I want to keep my lengths intact or my dimensions intact around this x squared to help me out. So I use that one, I've used that one, so now I go 1 for you, 1 for you. Okay? And up to this point right now, I want to show that I'm building upon my dimensions. The x squared tile had a dimension of x by x, so I'm going to label that x, label that x. And to show that I'm being in proportion, this x tile is important that we know that this little short length is a length of 1. So this is a length of 1, length of 1. Okay? Length of 1, length of 1. So right now I'm in proportion x, 1, 1, x, 1, 1. Now comes the challenging part. All right? What do I do with this last x? Remember I said that we had to use all the x's. There's no rules in mathematics. I can always do whatever I want as long as I have the same amount at the end of the day. I can change the composition of it, but I can't change the value of it. So, and I like to equate that to cars. I can go to the store and buy a green Honda, and when I get off the lot, I can change the color of it, but it's not going to change the value of it. If I buy a green Honda and then I paint that green Honda orange, it's not going to change the value of it. It might change what looks I get, but it's not going to change the value of it. It's still a Honda. So this one here, I'm actually going to go along with some scissors. I'm going to cut it in half. I'm going to go cut it in half lengthwise, cut it in half. So now I have this idea of a length of a half and a length of a half. So what I now have is a length of 2.5 by a length of 2.5. And what's important about that is that now this is going to be my ones area that I would fill in. I'm not actually going to draw it in there, but how many ones units I would have to make becomes relatively simple because this is a 2.5 by 2.5 grid that I'm going to have to fill in, which also becomes extremely nice. And a 2.5 grid by a 2.5 grid, if we end up multiplying them together, we get 6.25. And we're going to talk about what I do with that number and what I always use it for. So what's nice right now is that I'm done. This might look so weird and out of place to you, but I've built a square. That is Vertex form. It's actually building a square. I just now have to finish off and polish off the final pieces here. And here we go. So now that my square is built, here's how we finish it. One, I'm going to say what my square is. My square's dimensions are x plus 2.5. So x plus 2.5, right? And it's a square. So it's x plus 2.5 times x plus 2.5. So there's your square. Okay? The leading coefficient a was 1. So this is a 1 out here. All right? Now the question is how do I get this plus k? Well, it's very simple. I still have this plus 4. Okay? Plus 4 is still there. The question is what does the 6.25 do? Well, I needed 6.25. Now imagine this. You got $4 in your pocket. You want to go buy a candy bar, or you want to buy a bunch of candy that costs $6.25. What do you have to do? You got to go borrow $2.25. How do I know I had to borrow $2.25? Well, I find the difference between the two of them. So essentially what I'm going to do here is I'm going to take away, okay, find the difference between the value of the ones that I have and the value of the ones that I need. So I come over here and I write minus 6.25, and then I'm done. I clean it up, and then that's my vertex form completed. So I get y equals, so I don't have to put the 1 there, so I won't, x plus 2.5 squared minus 2.25, and then I'm done. Vertex form is now completed. And what I now know is that my h, okay, so I know the vertex of this particular one, so we base it off this, is going to be negative 2.5, okay, because a negative to a positive means that this 2.5 was a negative interpretation part. And the k is going to be negative 2.25. And then this is going to be the vertex of this quadratic. So let's make it a little bit more difficult. Let's change it. Let's change the signs. Let's not make everything positive. Let's just pick random numbers. Let's make this about as difficult and randomized as I possibly can think of. If you were here, I'd ask you just to give me numbers, but I'm just going to think of numbers at the top of my head and kind of go from there. So y equals, I don't know, let's go 2x squared plus 5x, and because we had plus before, let's go minus 7. So here we go. Remember, I'm going to draw out what I have, so I'm going to make my pot of collections. So 2x squared, so x squared, so 5x's, so 1, 2. Ironically, I chose 5 again. There's 5 of them. And these ones I never draw out because those can get pretty big. I just use it in the terms of whatever. So now, the important thing is that this number out in front tells me how many squares I need to build. And these squares have to be identical. So I have 5 x's, okay? I'm now going to play this game of building identical squares. I'm going to go, hey, you get 2, hey, you get 2, so that I can keep proportions. And then I'm going to go, hey, you each get a half. So a half, and then you each get a half, right? So what I now know is to build my square, okay? Both of my squares, they're going to be identical. I'm only going to build one of them, not going to draw both of them, because all I'm going to do is bump it up by 2, because I have 2 of them. So these go away. All right, and what I have left to build my square with is this. So here's an x, and then I have a half of an x. All right, so here we go. So I go 1 for you, 1 for you, and unfortunately I have a half that has to be shared, so I got to cut a half in half. Well, thinking about money, if you have 50 cents, you cut it in half, well that's 2 quarters. So here comes a quarter and then a quarter. Okay, so I hope you understand that this starts to go a little bit quicker as you get accustomed to it. So x, so now this is 1.25, 1.25. And that's where I come up with the lengths. Now, again, how do I get this number? Well, this is 1.25 by 1.25. Create that area, create that space, and to be honest with you, off the top of my head, don't know what 1.25 times 1.25 is. So I'm going to go over here and go 1.25 times 1.25, hit enter, and I get the answer is 1. This right here is 1.5625. So from here, what I do is I go through my process again. Now, the important thing is that there are 2 of these things, okay? So we start over. We're in vertex form. So this converts to, okay, that it becomes 2 of my squares that have a length of x plus 1.25 squared. All right, this is where I throw in that -7. Okay, and now I minus off this area, this last number. Now what we need to remember is I have 2 of these squares, so I need to double this number. So I take that number in my calculator and just do times it by 2, and I end up subtracting off 3.125. Okay, not this number. Remember, you need to double this number. Whatever this number is here, how many of these I need to make, we multiply that value by. And then I go through it. So now this becomes 2, so x plus 1.25 squared. So minus, so the nice thing is negative, negative, minus 10.125. And then I'm done. Vertex form is completed. I'm done. I've got nothing to do except for to say that my vertex for this one, if I were to write it, is at negative 1.25, comma, negative 10.125. And then I'm done. So I hope that helps with whatever it is you're working on.